Hello and welcome to the Peak Electronics booth. Peak Electronics is one of the leading manufacturers of DC-DC converters with a wide range of more than 20,000 standard types. This video is about selecting a DC-DC converter. In few steps we explain the most important criteria to select the converter optimized on the application needs. What is the difference between a regulated and an unregulated converter?
A regulated converter has an internal control circuit, which, for example, corrects the input voltage fluctuations on the output side. This means that the output voltage remains almost constant within the allowed range of the converter, even with input voltage changes. Likewise, the output voltage remains almost constant with changes to the load on the output. Regulated converters are more complex and expensive than unregulated. Unregulated DC-DC converters are above all used in applications with small power values up to around 3 watts. They do not have a feedback loop and cannot correct the above-mentioned fluctuations. For the majority of unregulated DC-DC converters, the input voltage may only differ by around 10% in relation to the rated input voltage. However, this can mean a fluctuation of the output voltage of up to 15%. In addition, unregulated converters need a minimum load on the output, as otherwise the output voltage is clearly too high, and this can even lead to damage to the device. Last but not least, unregulated types are either not at all short-circuit proof or only in the range of milliseconds. In summary, this means an unregulated DC-DC converter should only be used if it is ensured that the input voltage is very constant, better than 2%. Furthermore, the load on the output should ideally be in the range of 50 to 90% of rated capacity, and the risk of a short circuit as well as an overload can be excluded. For all other applications, a regulated converter is therefore always preferable.
When do I use a converter with multiple output voltages?
With regulated DC-DC converters, fluctuations in input voltage, output load and temperature only have a minimal effect on the output voltage. However, there are also converters with multiple output voltages. Converters with a split output voltage are often used, whereby 2 voltages of the same magnitude are available on the output connected in series. With respect to the 0-volt connection on the output, both -12 volts and +12 volts are provided, for example. In principle, it is a matter of a simple, regulated 24-volt output with a center connection. The output winding of the transformer that is built into the DC-DC converter is designed for a 24-volt output voltage and has a center connection for the additional 0-volt output. Only the 24-volt total voltage from the output plus 12 volt with respect to minus 12 volt is regulated, however not the 0-volt output. This means that with a different load from plus 12 volts with respect to 0 volt and minus 12 volts with respect to 0 volts, the 0 volts output drifts off. An example of this: if a converter with a 12-watt output power is loaded with a 0.5 amp on the plus 12 volt output with respect to 0 volt and 0 amp on the minus 12 volt output with respect to 0 volt, the plus 12 volt then drops to around 8 volt, while the minus 12 volt output arises to minus 16 volt. This means that the total of the voltages remains unchanged at 24 volts. However, the 0 volt connection has been shifted by 4 volts. Therefore, the load differences between the 12-volt outputs with respect to the 0-volt output should not be too different. If the loads in an application differ greatly, the least loaded output can be connected with a load resistor as base load to the 0-volt output. As an alternative, 2 separate converters can be used, especially when dealing with higher power requirements, or to avoid the power loss caused by the base load resistor. In general, in the case of converters with symmetrical output voltages, split output voltages, Not only the output voltage, but also the maximum output power is split. Therefore, with a 12-watt converter, only 6 watt can be drawn from each output voltage. For DC-DC converters with 2 or multiple different output voltages, often only one output voltage can be regulated and all others can only be coupled. In terms of output load, this represents an unregulated converter. If the additional output voltages are readjusted, all output voltages are stable independent of the output loads. Therefore, before the start of series production use of DC-DC converters, careful testing should be carried out.
Why should converters never be connected in series but in parallel on the input side?
Applications in which different voltage values are required can be implemented with several DC-DC converters. In doing so, as far as possible, the converters should never be connected in series in order to use the output voltage of the first converter as input voltage of the subsequent converter. The reason for this is that each converter needs a more or less high starting current, and it can very quickly happen that the preceding converter cannot deliver the current which is required to start the subsequent converter. As a result, the second converter is not switched on. Ideally, DC-DC converters are chosen, all of which can be operated with the available supply voltage. Hence, all DC-DC converters can be connected in parallel on the input side, which means that all minus inputs and all plus inputs, respectively, are connected to each other. The advantage of this is to provide each individual converter with an appropriate protection on the input side. In some applications, it can be necessary to provide LC suppression with one or several of the converters used. Thus, it can be avoided that the converters interfere with each other on the input side. As a general rule, linear voltage regulators can easily be connected behind a clocked DC-DC converter, since they usually do not require a high starting current. With most converters, a series connection on the output side is possible. In order to avoid that, during switch-on, as well as with a short circuit, one of the serially connected converters applies a negative voltage to the other and destroys it. Each individual output must be protected with a Schottky diode. The Schottky diode is connected between the plus output and the minus output.